Thank you, Dana. I also want to start by thanking the organizers of PyBay who invited me to come. It's been a great trip. And also, thank you all for waking up early on Sunday to come see me. So, this talk is actually very similar to the first chapter of my book. So, if you read the book, or at least if you've read the first chapter, then maybe the fun part will be seeing me actually presenting this material live and using a Jupyter notebook to do it. But, so, let's go. In the book, I actually quote this Chinese proverb, right? To build Pythonic objects, observe how real Python objects behave. And that's what I hope to show you today. Anyway, so like Dana said, I am a technical principal at ThoughtWorks. ThoughtWorks is an amazing company to work for because they are real pioneers in the Agile movement. So much so, actually, that two people who actually signed the original Agile manifesto work for ThoughtWorks. One of them is Martin Fowler, and the other is Jim Highsmith. So the company has been doing and really advancing Agile development practices since then. We were also pioneers in continuous integration. The most famous book about continuous integration was written by ThoughtWorkers, and then continuous delivery also. And also, it's a great company for women developers. We actually have women at the top level of the organization, like our CTO, Rebecca Parsons, but and the general managers in Brazil are women, and also as devs. I don't know the global statistics, but in Brazil, 30% of the devs are women, and we just got an award from the Anita Borg Institute. Is there? Yeah. Yeah, so we got an award for being the best company for women in tech a few months ago. And we are hiring, but who isn't, right? Anyway. And that's my book. I am really honored to be talking here to two of my tech reviewers, Anna Ravenscroft and Alex Martelli, who helped me make this a better book by doing the most careful tech review that you could possibly imagine. And it has been translated to other languages, and I'm really happy that people like it. And so let's talk about design masterpieces for a little bit. And I'm going to give you two examples. The first one is the Bauhaus chess set by Joseph Hartwig, which was designed in 1924, and then 70 years later, this other guy designed a programming language. This is the chess set. Look how beautiful it is. But it's not only beautiful, it's also simpler than the regular chess set. It's simpler to build, and it's simpler to learn to play chess with it. Because the bishops, for instance, have this X shape that allows you that reminds you how it works, and the knights also have this very nice shape that, however you put the piece, it's always an L on top. And also, if you look at the sides, it's kind of like the horse, right? So I think this is really very elegant, and I think that Python has many of these values. I actually have another talk about aesthetics in programming languages, in which I say that Python is a modernist language because of its clean design. Anyway, so let's talk about Python then. But to talk about Python, I'm actually going to do some live coding, but I'm going to cheat because I want to cover a lot of ground. So what I'm going to do is I'm going to use this Jupyter notebook, which has the code that I want to show. And then I'm just going to, but for people who hasn't ever seen a Jupyter notebook. Okay, so a few people. Just to explain what this is about, this is basically a web interface to a Python interpreter that's running on the background, and I can do just arithmetic here. So I got a result back. You can write Python code in these cells, and when you hit Shift-Enter, it will execute the cell and move on to the next cell. So it's really, it's very popular for data science. That's why sort of it was designed for. But anyway, I'm going to use it in this other way. So let's think about the problem that I want to solve with you here. Let's say I want to implement a class that represents a deck of cards. Okay, so and now putting my Pythonista hat, I think, okay, so I need something to represent the cards, and I need the deck itself. So let's talk about how to represent the cards. Basically, I want just a card to be an object that has two attributes, a rank and a suit. And the easiest way of doing this in Python, better? So the easiest way of doing that in Python is to use this named tuple function from the collections module. And what it does is it's actually a class factory. It builds a custom class for you with this name and these attributes. This is just a string with several attribute names separated by space. And so when I do that, notice the number 2 here means that I executed this cell. So now the environment of the notebook has this object called card with an uppercase C, which is the class. And here I am instantiating it. And here I'm going to actually unpack the beer card into rank and suit to show that it behaves like a tuple. But you can also read its attributes by name. All right, so we have something that represents a card, and it's actually interesting to see how the standard representation looks like. This is the standard representation. When you show one of these cards, it's very readable. Anyway, so we have a representation for the card. Now let's think about the deck. So the deck, a deck of cards can be considered a sequence of cards, right? Because you're going to pick them from the top. Maybe, depending on the game, you can pick from the middle, whatever, but if you're playing blackjack, you can only pick from the top. There's actually that machine that prevents you from picking from the middle. Anyway, so I have this. I need to represent a sequence of cards, and so let's get started with some constants that I'm going to use. So the first constant is actually just a list of the names of the suits, and this little trick here is something that I learned when I was doing RuBy coding, because it's easier to type than this, right? Anyway, so I have a list of words, and now I need a list of ranks, and this here is a list comprehension that will produce strings out of the numbers from 2 to 10, and then I'm going to concatenate a list made of these other letters. So I have this list of ranks, and now I can actually generate a list of all the possible cards by using another list comprehension. So here's the thing. Who hasn't ever used a list comprehension? All right, awesome. I think they are really expressive, and they make your code clearer than using a for loop. because a for loop can do many things, but a list comprehension always does one thing, which is to create a new list. So it conveys the intention better. So if I run this code, this is a list comprehension with 2 fors. So it's actually doing like it's doing a product of the 2 lists, and then results in this. So I have the list of 52 possible cards, right? All combinations of rank and suit. All right. So now let's start actually implementing the deck class. Now that I have this set of all possible cards. So the deck class, like I said, it makes sense to think about it as a sequence. And the way to do a sequence in Python is to create a class that implements those 2 methods. Dunderlen, so dunder is the way that we pronounce those names that have 2 underscores before and after. So if you implement the dunderlen method and the dunderGetItem method, that's the basic interface that you have to implement to be a sequence, an immutable sequence. Okay? So I run this code. Here's an interesting thing I want to mention. In the constructor here, or in the initializer, I create a list from the cards. Okay? The cards is already a list in this case, but later we are going to change this in a way that this conversion here makes sense. So now I have a deck that answers, that works with the standard len function in Python, because it implements this dunderlen. So one thing that people often wonder about is, why isn't len a method? So here's the thing. Why is it that in Java, the length of an array is not a method either? Right? The answer is because of performance reasons. An array or a list is such a basic, fundamental data structure that you want it to be as fast as possible. And getting the length of such a data structure is a very common operation. And you don't want to incur the cost of invoking a method. So for the standard list, actually for everything that is written in C as an extension to Python, or built-in, like lists and tuples and dictionaries and so on, what Python does when it sees this expression, the len of x, is it looks at x. If x is a built-in type or something implemented in C, it knows that there is a field in the struct that describes this memory, this object in memory, that has the size, and it retrieves that. So that's much faster than doing a method invocation. However, so that we can have a consistent language, which is one of Python's greatest qualities, you have to provide a way so that a programmer like me who is creating a new sequence type can play along with this convention that len is not a method but a function. And how does that work? Is when the interpreter realizes that the object is not a built-in or something implemented in C, then it goes to look at its Python class to see if it has a dunderlen method. So the dunderlen method is really a fallback so that our own classes can behave like the built-ins. And same thing with the dunderGetItem. This is actually the method that makes this work. So I'm getting the first card, the last card, the first 5 cards of the deck, okay? So I just unwrapped this deck from the packaging, so it's sorted in a way that many card decks are. Now, the interesting thing is that Python understands sequences very well. So much so that you can actually iterate over a sequence. So anything in Python that implements the len and the getItem is iterable. There's also this other formal protocol of implementing iter, but I won't have time to talk about it. But this also works, right? And the way it works, again, there's this built-in function that looks at an object and sees, so is this something implemented in C? So then it knows how to retrieve an iterator to iterate over it. If it's not implemented in C, then it's going to look for a iter method. But if there is no iter method, then it's going to actually look to see if the thing is a sequence. And what is a sequence is something that implements len and getItem. And so when I do this, I actually get this iterator. And now when I invoke next on the iterator, I have the next card. And if I do it with control return, this will execute the same cell and reselect the same cell. So you see, I'm really iterating over all of the cards. Okay, so this is a lot of functionality that we got, right, with just a class that has 6 lines in the body. And we didn't inherit from anything. It's not that I inherited from some magical thing. No, I just followed some conventions, right? And of course, a lot of this functionality is because I'm delegating, right? So when I do getItem, I actually pass this parameter, whatever it is, to the list method, okay? There is some, yeah, okay, so let's go on. Sorting. Let's suppose you want to sort this deck in a way that's different from the way it was packaged. So there's a standard sort ordering. It's called spades high. And this function actually computes a number where, you know, for the 2 of clubs, the index is 0, and for the A of spades is the highest card. The index is 51. And now I can actually pass my deck to the sorted built-in function with this index function as the key argument of sorted. And now I have a list of cards sorted by that criteria, which is different, right? Because now they are sorted by rank as the primary key. So another really powerful thing that we just did, just because we were able to do this because we leveraged the sequence interface. Now let's do some randomizing. So randomizing, for instance, Python comes with batteries included. And this was something that was the first time that I looked at Python in 1998. I went through the tutorial, and I thought it was awesome. I fell in love immediately. And one of the things that I thought was interesting was the fact that, for instance, it has things that I had implemented in many languages before already done. And one of the things is I want to pick an item from an array or a list or something randomly. And usually, you know, at the time, the programming languages didn't come with a function to do that. So you had to generate this random number and use it as an index and so on and so forth. But Python has random choice, right? So if I run this several times, we get a random choice from whatever sequence you pass. Again, the consistency, right? Anything that's a sequence, and it may be just a string, you know, can be used with the choice function. And of course, we can do that with our deck. So we got the 9 of diamonds. Let's do it a few more times. See? We can pick a random card. Now, of course, the other thing that you usually do with the deck is to shuffle it, right? And the random module also has a shuffle function. So here I'm creating a list of numbers from 0 to 19. And I shuffled it. The shuffle function works in place. So it needs to get a mutable sequence because it's going to change the items of the sequence in place and not create another sequence, okay? So let's shuffle our deck. Whoops. What we got was, and this was intentional, the deck object does not support item assignment. So when the implementation of shuffle was trying to do this, right, which is the extremely elegant way that we do a swap in Python, it needs to assign, you know, those items, and it can't do that. Why not? Because we did not implement the method to do it. So I could go up there, and edit the class, but I'm going to do something that's more interesting. I'm going to monkey patch. Okay, so what I do is, first of all, I simply create a function that takes as the first argument a deck of cards. The second argument is the position where I want to put the card. And the third argument is the actual card. And now, the implementation here is weird and may cause some people to freak out because I'm diving into the innards of the class function, or the class, the deck class, and actually reaching into this underscore cards. So underscore cards, this prefix of one underscore is just a convention that you shouldn't be mucking with this. But hey, I'm monkey patching, right? And that's what happens when you monkey patch. It means exactly what I'm doing. What I'm doing is I am inserting, but thank you very much for the question, Adi. So the monkey patching means changing code as it's running. So our deck class is already in memory. It's already working. We've been doing stuff with it, all right? But now I want to add functionality to it. And Python, because Python is a dynamic language, and actually the most important reason why Python is called a dynamic language is not because we have dynamic typing. It's because we can do this kind of thing, which means that the program structure is dynamic. At runtime, you can do pretty much everything. You can actually create a new class, which we just did, right? When I invoked the named tuple function, right in the beginning, that at runtime created a new class. You know, try to do that with some other languages. Many of them won't allow you to do that. Anyway, so, and in this case, I created this function, and this function has knowledge of the innards of the class, which is not okay, and that's why monkey patching is usually not okay. But it's something that sometimes you have to do, and it's nice that that Python lets you do it, right? So this is like one of the reasons why one of the creators of Plone, forgot his name now. Anyway, he likes to say, I actually quote him in my book, but I forgot his name now. He likes to say that Python is a language for consenting adults, right? Okay, so since we are consenting adults, yes, I am reaching into the innards of this class, but I've just created a function, right? Now, if I assign this function object to this attribute, then I get a deck that can be shuffled. So this is what monkey patching is. At runtime, I added functionality that did not exist in the class. Okay, so this is nice that I actually prepared all this code and not typed it like I did the last time that I presented this talk, because now we have time to do more interesting things. So let's talk about operator overloading. Okay, so this is a a fuller implementation of the class. It's complete here. Is this 20 lines, and line 16 is the implementation of the under add method, which makes the plus operator work with instances of deck. So I'm gonna run this. So I just redefined the whole class, and I'm going to create a new one, and I'm going to get the top 5 cards. Whoops. Oh, okay, yeah. Minor typo here. See? Anyway, so notice that I did a change here, because the first version of this has a minor inconsistency. It's an inconsistency that may be a problem in some situations. And the inconsistency here is that when I do get item and I pass a slice like this, what I'm getting is a list of cards. And that maybe could be a reasonable choice in some situations. But probably the more consistent choice would be to return a new deck with those cards and not a list, right? Especially if the deck is not just going to behave like a simple sequence, like the initial one, but if the deck is going to have other methods, like, for instance, the Geo method, which I created here. So in order to return another deck when the user passes a slice as the argument to get item, this is the code that you need to write. So you check whether this I argument is a slice. So a slice is a built-in type that Python uses to represent that slice notation with colons, right? And if it is, then I return a deck built from the cards taken from that slice. Okay, so another thing that I needed to do here to make this work was to have a constructor that now accepts a list of cards. If the list of cards is not provided, it uses just the default cards. But otherwise, it does this. This line here serves two purposes. This expression here serves two purposes, because a lot of people would do this, and I did this for many years, okay? So who knows what's the problem with this? Yes, the first problem, that's the biggest problem, is you are sharing the reference to the object that was passed as argument. So if you modify it here, like for instance, if you shuffle it, you're going to shuffle the list that the person passed to build the deck, and it's likely that she may be annoyed. Okay? But there is another advantage so doing this actually creates a copy. Okay? So I am copying that list, whatever is passed, and the whatever is passed here is the second advantage. The second advantage of doing it like this is that now I am playing well with duck typing, but in a safe way. Doing it like this means that I can accept any iterable object as the cards argument, because the list constructor knows how to build a list from any iterable object, right? So this code is now also safer, because if somebody passes something that is not iterable, they're going to have an error right there at the construction, instead of later when you're trying to do some operation on the structure, right? So I think this is a very good practice especially with mutable collections. Of course, sometimes you have for optimization reasons, you can't afford to do that, because if you're getting lists of millions of items, probably we won't be able to copy them. Or anyway. So, so I had these two changes here. The first was accepting the cards argument on the dunder init, and the get item now that handles differently the case of a slice. Okay. So just to show, we have this top 5 cards, and I'm gonna take the bottom, which is actually deck, the bottom 5. All right. And now I can add them. See, and what I got was another deck. Let's take a look at this deck. Right? So, because this is how you implement, it's more complicated than that to handle some other cases, all right? This case here, this works if, this works as long as the addition is performed between a deck and the other thing must be an iterable, hopefully containing cards, right? And this will create a list of the concatenation, concatenation of our deck converted into a list. I need to do this conversion so that I can use the plus operator built in, right? And the list of the other thing. Yes? Yes, if I had an iterable of something that doesn't produce card items, then my program would not detect this problem right here, and we would have a problem later. Too bad. It is, but it also provides other advantages. The thing is, everything in life has good parts and bad parts. Okay, so dynamic typed languages save you a lot of work, because you can implement a generic function without having to learn generics, you know? And that's awesome. So it allows you to be very productive. But then it has this other problem that the types are not checked when you compile the program, only when you run it. So sometimes you have bugs that occur later. Consenting adults, yes, exactly. Okay, so what else do we have here? Oh, okay. Let's talk about the Geo card, the Geo method. So the Geo method is the only normal method here that's not a dunder method, right? No, just to be clear, for the people here who are beginning with Python, most classes that you're going to write don't have so many dunder methods. But if you're going to implement a class that you want to make it so that it behaves like a built-in collection, then you are going to implement dunder methods. Okay, so now the Geo method. So what does the Geo method do? And this is, again, Python is so elegant that, it's incredible. So how do you deal cards? Like, for instance, when you're playing bridge. You give one to this person, the next to that other person, and like that, all right? So each person will actually get a sequence that can be built by this expression, which is a slice that starts at the I position, where the I position is the number of the player, and that skips the number of players. So the first person gets card number 0, card number 4, card number, and so on and so forth. Okay, makes sense? So this expression creates 5 lists of cards. And I can check that both A and B got 13 cards. And let's take a look at the cards for C. So that's C's hand. Okay. Anyway, so that's how operator overloading works. And it's simple and elegant. You need to do other stuff here in the ad. For instance, if you want to be able to work with different kinds of objects and so on. But this works perfectly for a deck and a list of cards, which can also be another deck. Now, yes. What? Okay, so this is part of no, it doesn't have to do with list comprehension. This is part of the slice notation. The slice notation, which is usually just one column, you can actually put, if you had another number here, it would be a slice from I to X, excluding X. But the third part, which is optional in a slice, is a step, which is a number of items that will be skipped. Okay? But you can omit it like this. Okay, so does that make sense, folks? Yes. 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 Yeah. Make it lazy, you said? Yes. Okay. Sorry? Oh, well, no, I was quoting somebody else, actually. Maybe Joe Burton invented that phrase, but I heard it from somebody else. All right, awesome. Okay, yeah. Yes, there's a way to make it lazy. But here's the thing. In this particular situation, I really need to transform these two things in lists so that I can use the plus sign. Sorry. What? Yes, okay. The thing is, all right, you're right. This is an optimization that I can do. I can actually reach into this, but again, there was also a point in doing it like that, because what I was showing is that now I can just, use this as any sequence without, but anyway, this is a good optimization to avoid copying the first part. And the second thing, I need to transform into a list so that I can use the plus operator as it's implemented for lists. Okay. If I wanted to do an iterable, well, okay, so add, and here's the thing. Arithmetic operators in Python, usually, by convention, they should always build a new object and not modify at all either of the arguments. Okay? So I don't really see a practical way of avoiding this duplication here, because this serves another purpose, right? And I want to remember. I want to make this copy anyway because I don't know where this is coming from, and so yeah. No, in the ads. Ether to chain. Yeah, that's good. Yeah, we can do that. Yes, we can do that. Let's do that.
I was also going to suggest if the deck accepted a sequence of cards, you would avoid that list. And that would also allow you to take two decks.
But the deck accepts a sequence of cards.
Well, no, a list of cards. That way you could take 3 decks, like in
blackjack. A list of several decks.
Yeah, that way you could take 3 decks and turn them into one, and that's what you'll deal blackjack out of.
Yeah,
you're going to play with,
104
cards or whatever.
Yeah, exactly. So the idea from using ether to chain, that's a good idea. That is also a good idea, by the way. Thank you. So ether tools And then I can go like this. And I hope it's, I don't remember if we take several arguments of, if I, well, let's. So like this. What? What? So we have 10 minutes. This is getting exciting. But it's great, people. Thank you. Okay, so I'm using the help. Oh yeah, all right, a bunch of iterables. Yes, okay. Yes. Whoops. Yes, it worked. Awesome. Thank you for. Yeah, so this example was from the first chapter of the book, and I didn't want to introduce too many new concepts in this chapter, but the book covers very well iter tools and other neat stuff in Python. So, so we did this thing that does a lot of stuff that is pretty advanced, you know, for people who work with other languages. Like, for instance, I am now practicing Go, and Go doesn't have operator overloading, for instance. So just like Java doesn't either, right? So the Java designers, I actually found a quote that I mentioned in my book by James Gosling, where he says that out of the many features of C++ that they left out when they invented Java, the one that he was most torn about was operator overloading, because he knew there were interesting use cases for it, but it was also a feature that was abused. But in Python, it's actually, I submit that is a key part of the success of Python today, because Python is growing a lot because of analytics, right? And let's just run this code here. So this plots the height of an object that is thrown vertically with a certain initial speed. Okay? Now, thank you. Take a look at this code. It's just beautiful, right? You know, in order to generate the graphic, I need to generate a set of points, right? A set of coordinates. So where's the for loop that does that? Huh? I'm generating a bunch of, I'm actually generating 1,001 positions. Okay? So where's the loop that does that? Yeah, so the loop that does that is extremely optimized in C, and depending on your configuration, maybe this loop will actually execute, at least part of the functionality here, will execute using your GPU, doing vectorized operations, right? So this creates an array with an arithmetic progression of numbers from 0 to 1 with 1,001 positions, right? And this here beautifully leverages operator overloading to compute this as vector operations, right? So the T is an array, is a vector, right? So when you multiply T times V0, which is this scalar number, now you get another array that has all of those positions times V0, right? And when you do this, you get this another array that has the values squared, each one of them squared, and then you multiply by G, and then you get another array that has all of those values multiplied by G, and then when you divide by 2, you have, so lots of arrays are being created, but this is extremely fast because it's written in highly optimized C code that may actually leverage your GPU to do that. And then, yeah, so this is just beautiful. And if you need to do that in Go or Java, it's going to be not beautiful. Okay. Anyway, yeah, so this is my talk. Basically, I'm going to just go back to the slides. If we are going to open for questions, I'm just going to say, so my Twitter handle is the second one, Ramalho.org. I actually have the Twitter name Luciano. However, it's useless because a lot of millions of people don't understand the syntax of the @calls. So people say, oh, yesterday we had very nice dinner at Luciano space blah blah houses, and that's not me. So Luciano is a common Italian name and also sort of common in Brazil. And what happens is I had thousands of notifications every day that had nothing to do with me. And then people started getting annoyed at me, saying, well, why don't you, interact with me on Twitter? It was because I couldn't find the notifications that were actually for me. So I invented this handle that works to filter that problem. But now I realize it's also difficult to pronunciate and so on. So I just created this other one a couple weeks ago that I'm going to start using. So stand-up dev. I like to say that I am a stand-up developer because this is the kind of developing that I like to do at this age in my career. Live coding and explaining things to people like that. So I'm a stand-up developer. And the Twitter handle, I already tweeted the slides for the tutorial that I gave, that Adi was there. And those few slides, I don't know if I'm going to put them there. There's just too few. But anyway, thank you very much, and let's open for questions. And thank you, Anna, for the water. You guys are so great. I'm so happy to be here at PyBay. This is already perhaps my favorite Python conference in the US. So, questions, comments?
From the list. So how do you decide, I mean, this
Well, in the design patterns book, they say favor composition over inheritance, right? So this is a good tip. When in doubt, do it using composition. And that's what I did, right? So because a lot of the functionality that I implemented is actually in the list that is embedded in the deck class. Yeah. So I don't know how to answer that in general. It's difficult to answer that in general. I would like to say that for when you inherit from the built-in types in Python, there are some issues. Okay, so it's not always advisable. So in fact, for instance, there is to inherit, if you want to create a dict-like object, you actually should inherit from something called a user dict. There is this class called user dict that is designed to be inherited by your code, and it works better than the dict, the original dict. And the way it works better is because there are some optimizations in the built-ins that sometimes they won't actually call your methods if you override the method, because the C code in there thinks it's actually dealing with the native dict, and it will do stuff behind your back. But it's an optimization, and I think it makes sense, because the dict is so important, for instance, in the standard library, and for everything in Python, right? Everything in Python are dictionaries, right? A module is a dictionary of attributes, a class is a dictionary of attributes also, and so on. Other questions?
It's really relevant. In the Bauhaus chess set, which one is the king and which one is the queen?
Oh, okay. What do you think? No, the queen is the sphere. And to me, it makes sense, because in a way, it's like the queen moves in a more global way. That's how that's my, you know. And the king is kind of square, just, you know. Sorry? Oh yeah, I'm gonna post it. I haven't posted it yet. I'm gonna post it on Twitter, okay? I haven't posted this, which I just did, okay? Yeah.
Hi.
Hi.
So we can see that you're using Python from around like close to 20 years for now, like, and you have seen the way it's been grown over all this 20 years. So like in next 3-4 years, what do you think is going to be future of Python?
Okay, great question. So I think the most exciting things that happened recently, like in Python 3.6, was, well, in Python 3.5, the introduction of await and async syntax. This is just in the beginning of this revolution. I think we're going to see this growing importance in the language. Python 3.6 went further down that road by creating something called an asynchronous list comprehension, and also this hybrid thing called an asynchronous generator. So, and Yuri Selivanov, who is the guy who invented the await, who brought the await and async syntax to Python, also wrote these other PEPs. I think he should get a medal or a statue from the community. And he claims in his recent PyCon 2017 talk that Python now has the best syntactic support for asynchronous programming using async await of all languages, because we can do asynchronous context managers. You can say async with, which means that the initialization and the termination of the block will be done by coroutines. And you can do async for, which means the iteration will be done with the next method that's going to be used in the iteration can be asynchronous as well. So it's really amazing, these things that are happening. I'm going to be really frank and say that I don't like very much, I'm not a big fan of the Async I library. It works. I think the documentation is unfriendly to beginners, and it's something that they are working on for 3.7 to do a big refactoring of the documentation. But I think it's really intriguing the things that other people are doing with Async I/O, not Async I/O, with Async with the syntax of the so-called native coroutines, which is the work of David Beasley with the Curio project, and there's another project called Trio, whose author is called Nathaniel, but I forgot his name, and he's from around here. I think he works at Berkeley, so you should invite him to talk at PyBay. Anyway, he invented this other framework called Trio. And those two frameworks are frameworks that use the async await syntax in a way that is, I think, more elegant than Async I/O does. And here's another thing that is really great about the design of Python, is because the design of Python is really so open-ended. And so one of the things is other languages had async await before, like C#, for instance. But in most languages that implemented, as far as I know, in all languages that implemented this syntax before, the syntax was tied to a built-in scheduler that was the event loop that was built in the language. And Python didn't do that. The implementation uses this standard dunder hooks, right? So dunder a iter, dunder a next, and so on and so forth. So you can actually plug it to whatever scheduling mechanism that you want to invent. And this opens this syntax feature to a lot of innovation on the implementation side, which is not possible in other languages where there's this tight coupling between the syntax and the implementation that comes with the language. So I think that's the most exciting things that are going to happen in Python, is to see the community adopting this new style of programming and doing more stuff with it.
Last question. You mentioned that you are using Golang these days. So what's the reason and what are the advantages of Golang over Python?
Okay, so I think Go is a very interesting language. One thing that you have to know about ThoughtWorks is that we are not committed to this or that specific language. We hire devs that we expect them to be, polyglot, because different projects require different languages, right? I'm studying Go because of its concurrency. Also because I'm old enough that I lived when there was still a debate between C and Pascal, and I was of the Pascal side. And Go is the revenge of Pascal. In many aspects, Go is very much like Pascal. It has this inheritance. Actually, in the canonical Go book, they actually have this tree that shows the DNA of the language, and there's a lot of DNA of Pascal there. It's the mainstream, actually. And so I find Go really interesting. But I have another talk that's called Go from the point of view of a Pythonista, where I say some nice things about it. But the worst thing I say about it is just a code example that I show. The same thing implemented in Python and Go, and the Go code is 3 times as long. So.
All right, let's thank Luciano for an amazing talk.
All right, thank you very much.